this segment, we're going to talk about the different layers of the sun. So here I have drawn the shape of the sun. When you look at the sun from your point of view on Earth on a nice clear day, and you only look at the sun when it's very low in the sky at sunset and sunrise, you see the sun, that layer that you see of the sun is called the photosphere. Let's put our definitions on another page. The photosphere is the bright visible surface of the sun. It is the surface that you see with your eyes when looking from Earth towards the sun on a bright sunny day. The photosphere is an atmospheric layer of the sun. Now just above the photosphere is a layer of the atmosphere called the chromosphere. Now you typically only see the chromosphere when there's a total solar eclipse. So when that moon is crossing in front of the sun, you might see this pinkish layer right around the sun, and that pinkish layer is called the chromosphere of the sun. The chromosphere are bright gases, is a layer of bright gases just above the photosphere. Now the atmospheric layer above the chromosphere is called the corona. The corona is the faint outer atmosphere of the sun. It is composed of low density, very hot gas. Now in astronomy, words tend to take on multiple meanings. In this case, the word corona applies to the sun, and corona also applies to Venus. Corona for Venus is a round network of fractures of ridges up to 1,000 kilometers in diameter that are caused by the intrusion of magma below the crust. We are not talking about that definition of corona. We are talking about the sun in this chapter, and we are talking about the corona atmospheric layer of the sun, which is the faint outer atmosphere of the sun. It is above the photosphere and above the chromosphere. These three layers, the photosphere, the chromosphere, and the corona, are the atmospheric layers of the sun. As shown in this cartoon and this image from your textbook, the photosphere is this yellow-colored region, and it refers to the lowest atmospheric layer of the sun. The chromosphere is this pink layer, and that pink layer is the middle layer, atmospheric layer of the sun. Now, as shown in this image, the corona actually appears white here, but up in this portion of the cartoon, it appears blue. The blue portion of the corona is the lowest portion, right above the chromosphere, and it extends up, getting fainter and fainter and fainter in lighter colors of blue, until finally it looks grayish or whitish on the outside. So that is why I colored the corona as the color, this grayish whitish color. These are your atmospheric layers of the sun. Let's move to the interior layers of the sun. In the very center of the sun, we have the core of the sun. The core of the sun is the region where nuclear fusion occurs. Nuclear fusion is a reaction that joins the nuclei of atoms to form more massive nuclei. So in other words, you would combine a hydrogen atom with a hydrogen atom and a hydrogen atom and a hydrogen atom. You combine these atoms and eventually you create a helium atom, a higher number nuclei on the periodic table. Above the core, we have the radiative zone. The radiative zone is a region inside a star where energy is carried outward as photons. So the photons are generated in the core of the sun, and then the photons are moving outwards through the radiative zone. And these photons carry energy. Now remember that the photon is just light, and so this region of the radiative zone is just light. Just above the radiative zone, but below the photosphere, is a region called the convective zone. The convective zone is a region inside the star where energy is carried outward as rising hot gas and sinking cool gas. So in this convective zone, we have rolling gases. So remember, the radiative zone is nothing but light. The core is where this light or these photons are created. And so it isn't until you reach this convective zone where you have this gases, this actual material moving up and down. An analogy for the convective zone is a pot of water. So let's say you've got a pot, you've got some kind of burner that is heating up your water, and the first thing you notice when you're watching the water trying to get it to boil is that you form these bubbles at the bottom of the pot. And then what you see is these bubbles of gas, they slowly start to rise. You see them rising to the top, and then they pop. The bubbles pop at the top, and what they're doing is they're releasing that gas. So this hot gas is being released at the top of the pot. And then over time, what you start to see is this rolling boil that occurs. And what you're doing is you're dragging hot gases up to the top, and you're rolling around the cool gases down to the bottom of the pot to pick up the heat and carry it to the top of the pot. And now you've got yourself a rolling boil. Well, that's the same thing that's going on inside this convective zone. You've got this rolling boil. You've got the gases coming from the bottom of the convective zone that is transferring energy to the top of the convective zone to that atmospheric layer that you can see called the photosphere. So, from the interior of the sun to the surface and up into the atmosphere of the sun, we have these layers. We start with the core, and we increase outward, going through the radiative zone and into the convective zone, and right at this region is where we start the photosphere, that first atmospheric that atmospheric layer that you can see with your eyes, and that is that yellowish region that you see from the surface of the Earth. Above the photosphere, you've got the pink chromosphere, which you see only when you have a total solar eclipse. You would see that pinkish region. And then above that, in a completely dead-centered total solar eclipse, you see the bluish to white corona outside of the chromosphere. And these are your layers from inside to outside. Now, although this is not an actual layer, we are going to add a solar wind to our diagram. The solar wind is particles. They could be atoms, or they could be atoms that have gained or lost an electron called ions. So are these particles that are rapidly moving away from the sun, and they have escaped from the corona. So they're rapidly moving escaped particles from the corona layer of the sun. And these escaped charged particles penetrate throughout the solar system. They come past Mercury, past Venus, past Earth, past Mars, and they keep flowing out away from the sun and through the solar system. These are your layers of the sun. As shown in this cartoon diagram from your textbook, the core of the sun is where these photons are being generated. And these photons make this random path through the radiative zone, outward to the base of the chromosphere, base of the convective zone, where the energy is being carried out by this hot gases that are rising and these cool gases that are sinking, creating this rolling boil in this convective zone. The photosphere is not shown here, but it would be right there at the top of the convective zone. The chromosphere, if you can see it, is this little hint of pink that you can see. And the corona is this blue region. These are your layers of the sun.